Hey, this is Ian Parberry, author of Introduction to Game Physics with Box 2D, and I want to talk to you today about section 2.4, Gauss-Seidel relaxation. Here we are animating two particles bouncing around on the screen, bouncing off the screen edges. To make it interesting, every so often I apply an impulse to the particles here, so that they fly around kind of at random. I have a little bit of friction on the edges, so as you can see there, occasionally one of the balls gets stuck in a corner where it gets friction from both edges. So I'm using material from chapter 2 here. From section 2.1, of course, I'm just using a lot of basic math. From section 2.2, I'm using bouncing off the walls. From section 2.3, I'm using Verlet integration to move the balls so that it doesn't really matter. It doesn't show up on the screen. It would look the same if I were using Euler integration. It just makes the coding a little bit easier when I get to section 2.4, relaxation. So right now I'm not using relaxation, but I will in a minute. So notice the balls independently just bouncing around at random. So let's start by putting a constraint between them. Let's constrain them so that the distance between them remains constant. Here we go. Nice. So what I'm doing now is I'm applying one constraint, the length constraint, using Gauss-Seidel relaxation. That is, I move the particles independently, and then I go in and check, is the length wrong? If so, then I move the circles together, closer or further apart, whatever's necessary. Alright, that's not too hard to do. The way the human mind is, if you stare at this demo for long enough, you'll see a phantom stick joining these two particles. There really isn't a stick there. But we'll go ahead and draw one. Here we go. There. I've drawn a nice big thick stick so you can see it properly on the video. And it bounces around on the screen just as if it were a real stick. Again, not too hard, just a bit of rendering and we're done. It gets really interesting though when we try to do things with multiple sticks and joints. So let's take two sticks joined together at one end, like this. Now as you see them bouncing around, so the two sticks stay joined together and they stay the same length. That's just a matter of applying Gauss-Seidel relaxation to both sticks, but they share a common point. So if we apply Gauss-Seidel relaxation to one stick and it gets to the right length, and apply it to the second stick, well, it may mess up the work that was done for the first stick. So okay, let me go back and forth. First stick, relax, second stick, relax. First stick, relax, second stick, relax. Well, that's the beauty of Gauss-Seidel relaxation. If we apply only a few iterations on each pass, on each stick, that is, it's guaranteed to eventually converge to the right solution, with the two sticks having the correct lengths and being still joined at one end. Now, a mathematician would probably think, oh yeah, I need to test if it's right, and then if not, then relax some more, but we don't need to bother with that. What we're going to do is just apply a few rounds of Gauss-Seidel relaxation. All we really care about is that it looks good, that any area is less than a pixel. So I'm just going to apply Gauss-Seidel relaxation a few times, maybe 2, 3, 4, 5, whatever makes it look right. Now, there's something else I can do pretty easily, and that is relax my approach to Gauss-Seidel relaxation. Why I do fewer iterations than I really need to make it look good. What happens then? So we'll go back to a single stick with too few iterations of Gauss-Seidel relaxation. Here we go. Here's what happens. We get springs. Now, this turns out to be far easier than coding up springs with Euler integration, so big win for Verlet integration here. I've gone ahead and drawn a ball bearing for each particle, and I've drawn a spring in the middle that stretches. So, for free, by not doing as many iterations of Gauss-Seidel relaxation, we go from sticks to springs. Cool. This would look really cool, or would be a really cool multimedia experience if I had some sound. Like this. Well, that's all for now. I'll be delving more into the engine that I used to make this demo in 2 chapters from now, in chapter 4. So until then, bye for now.